Dear friends, from today's lecture we are going to start with the syllabus. So for our choice grade credit system related syllabus of B.Sc 3 chemistry, there are 4 papers. This paper number 10, which has a number DSEE6, is of organic chemistry. The theory credits is 2 and 30 hours or 38 lectures is the time allotted. So in this topic, in this paper particularly, we are going to learn introductory part related to spectroscopy, then UV visible spectroscopy, infrared spectroscopy, NMR spectroscopy, mass spectroscopy, and combined problems. So out of these topics, I will be dealing with the topic of UV visible spectroscopy and infrared spectroscopy. So friends, this is one of the best branches, and it is an important tool. Spectroscopy is an important tool in organic analysis, in chemical analysis in general. So before going into details of these various techniques of spectroscopy, we must have some background about the new branch. So today we are going to see the fundamentals of spectroscopy. To begin with, we must know what is the meaning of spectroscopy. In any branch of learning, everything must begin with its definition. So in spectroscopy also it is very essential. So what is spectroscopy is, it is the branch of science that deals with the interaction of matter with electromagnetic radiation. So friends, there are two things very important. One is matter, other is electromagnetic radiation. In other words, it is the branch of science in which electromagnetic radiation of particular wavelength or range of wavelength is used for qualitative and quantitative analysis of matter. Again, the same second definition also explains the same thing. So what is matter? Matter is anything which occupies space in universe and having mass. So this matter and its interaction with electromagnetic radiation is to be studied in spectroscopy. What is the meaning of electromagnetic radiation? Wave produced by motion of electrically charged particles known as photons is electromagnetic radiation. It consists of two components. One is electric component and other is magnetic component. So in our earlier classes, we have seen the fundamentals repeatedly. Let us revise in brief once again. So the wave is propagating, the direction is given, and you will find that from source to the direction, when the wave electromagnetic radiation propagates, there are two components, and these two components are one is because of electric field, other is because of magnetic field. So electromagnetic radiation means it is a combination of electric wave and magnetic wave. Both of these are perpendicular to each other and perpendicular to the direction of propagation. So this is again the similar kind of picture. This figure again indicate some parameters. It explains wavelength, it explains the direction of propagation. We are going to see the details in next few slides. So this is in brief electromagnetic wave, which has two components. One is electric component, other is magnetic component, and whatever we say light is the visible part of this electromagnetic radiation. So there are various interactions. When matter interacts with this electromagnetic radiation, various interactions are observed. What are these? So these interactions are reflection, absorption, emission, scattering. The interactions in the form of responses are recorded in the form of a spectrum. So what is spectrum? Spectrum is the recorded response in between the electromagnetic radiation and the matter. A plot of the response as a function of wavelength or more commonly frequency is referred to as a spectrum. Spectrum is nothing but it is a plot. It is a plot where the response as a function of wavelength or frequency is plotted. Okay. The word spectrum was first used by Issac Newton for the first time in 1671. So he investigated that when a white light beam is passed through prism, there is a separation of different colors, and these separated colors he called as spectrum. The interactions are functions of atomic structure and molecular properties. So atomic structure and molecular properties are investigated by spectroscopic analysis. The instruments used for these investigations are called as spectrometers, or these are also called as spectrophotometers or spectroanalyzers. In various branches, the instruments are specifically labeled or specifically known. To know the interactions, one must know the nature of electromagnetic radiation. These are best explained by considering some fundamental parameters. As I mentioned, Isaac Newton for the first time found that when a beam of white light was passed through a prism, these colors were separated. So violet, indigo, blue, green, yellow, orange and red. So it was the first spectrum and thereafter such techniques were used widely, and there are various applications. Now the properties of the waves or electromagnetic radiation are explained with the help of various parameters. As I mentioned in the beginning, these parameters are, first parameter is wavelength. What is wavelength? It is the distance between two successive or nearest crests or troughs. The wavelength is measured in different units in different spectrophotometric analysis. So in UV it is angstrom. 1 angstrom is equal to 10 raised to minus 8 meters, or it is in nanometers, it is equal to 10 raised to minus 9 meters. The frequencies again are very essential. The number of waves passing through a point per unit time is called as frequency. It is measured in terms of hertz or cycles per second. Wave number is another parameter. Wave number is number of waves per centimeter per unit distance, and amplitude is the maximum height of the wave. So this figure indicates the wavelength and amplitude as well. The relation between frequency and wavelength is given by C is equal to nu lambda, where C is velocity of light, nu is the frequency, lambda is wavelength. So this general equation is very essential in spectroscopic analysis. So again the same formula, the symbols are given, velocity of light, then its frequency and wavelength is given. There are various branches of spectroscopy. So we will have general idea. One is called as absorption spectroscopy. This branch uses the range of electromagnetic spectra or radiations in which the substance absorbs some of the part of the electromagnetic radiation. This includes atomic absorption spectroscopy and various molecular techniques such as UV spectroscopy in UV region, infrared spectroscopy in that particular region, and NMR spectroscopy in the radio region. Means absorption spectroscopy is related to absorption in various range or various ranges of electromagnetic radiation. Okay, there is one branch called as emission spectroscopy. It uses the range of electromagnetic spectra in which the substance radiates or emits some of its absorbed light or absorbed electromagnetic radiation. The substance first must absorb energy. This energy can be from a variety of sources, which determines the name of the subsequent emission. like luminescence, molecular luminescence technique include spectrophotometry also. So one technique is called as absorption spectroscopy, other is called as emission spectroscopy. There is third branch which is called as scattering spectroscopy. It measures the amount of light that substance scatters at certain wavelengths, incident angles and polarization angle. The scattering process is much faster than absorption or emission process. One of the most useful applications of light scattering spectroscopy is Raman spectroscopy. So these are the common types of spectroscopic techniques. Out of these, as I mentioned in the beginning, that we are going to learn UV spectroscopy, infrared spectroscopy, NMR spectroscopy and mass spectroscopy. So these things are to be studied in detail with reference to organic chemistry, because these are to be applied for organic compound analysis. So this is the entire range of electromagnetic radiation which explains the different regions, their relative frequencies, wavelengths and which affect particular excitations in the molecules. Okay, so different effects which are observed in case of organic compounds are, whenever the electromagnetic radiation is irradiated on matter, there is excitation, and these excitations are of various types. In UV spectroscopy, electronic transitions or electronic excitations are observed. In infrared spectroscopy, there are vibrational changes. In microwaves, there are rotational changes. In general, in case of infrared, we study vibrational and rotational motions, vibrational and rotational changes. And the radio waves are studied in NMR spectroscopy, and nuclear spin transitions are observed in that particular region. Four primary techniques commonly used since 1960 are UV visible spectroscopy. Then second is nuclear magnetic resonance spectroscopy. Third is infrared spectroscopy, and fourth is mass spectroscopy. The spectroscopic techniques except mass spectroscopy are non-destructive and require very small amount of the compound, to be investigated, and that is why these techniques are very popular. These techniques are very fast, accurate and explain various things related to molecular structure. What information do they give is the question. So the first technique, infrared and UV visible spectroscopy, these explain presence of or absence of functional groups. Of course, limited information about connectivity is obtained. As I mentioned, UV spectroscopy is related to electronic excitations, UV visible spectroscopy, and infrared spectroscopy is related to vibrational and rotational changes. Mass spectroscopy gives information regarding molecular weight, from which molecular formula and some additional information can be obtained. In case of NMR spectroscopy, there are several types, 1H, 13C, 2D techniques, etc. Further information about functional groups and connectivity is obtained. So NMR spectroscopy explains the nature of protons present and its functional nature. So with these integrated information, we can explain the structure of a molecule, and properties can be correlated with the structure again. So that way spectral analysis becomes very popular. So friends, being the first lecture, we have seen some fundamentals. Considering the relation E is equal to h nu, you can calculate energy, then frequency, wavelength can be correlated. So basic equations, basic relations and calculations are to be carried out by using this fundamental relation. From next lecture, we are going to see the further details. In particular, I will be dealing with ultraviolet visible spectroscopy from next lecture. So for the time being, go through these fundamentals and revise these again, and try to carry on basic calculations related to energy, frequency, wavelength, etc. So thank you.